Just as intro, my name is Tushar Dhanani. I am a senior end user computing specialist solutions architect with AWS. I've been with Amazon for about 3 years now. And today we're going to talk about one particular end user computing service. It's called AppStream 2.0. It is a fully managed, non-persistent application streaming service that lets end users connect to their desktop applications from anywhere and practically from any device. So I've framed the session from a bird's eye view. So we're gonna look at high level, what the features are, what the service does, some of the use cases, and then we'll dive deep into some of the newer features and also some of the most important features. So before talking about AppStream, I just wanted to take a minute and talk about how workforce has been changing for the last, I would say, 5 years or so. So according to some of the studies that were done in 2020, before the pandemic or COVID has actually accelerated the growth of remote working or a remote workforce. But before the pandemic, the study said that 1 in 5 jobs that were performed at any organization were actually held by contractors. So that's about 20% of the companies that were hiring contractors for performing their duties. And then 79% of companies were looking at mergers and acquisitions. So these were companies that were trying to acquire new employees or were trying to hire and onboard newer companies when there was more people that needed to onboard in a less amount of time frame, and they needed to provide virtual or physical desktops to each one of those employees that they were merging with. And then on the other side of it, there was a different study that was conducted, and about 69 countries around the globe were a part of this study, where they found out that once per week, almost every employee in their organizations were working remotely. So after COVID, everything has changed. We first started out with going fully remote, and then now everybody has kind of switched to a hybrid environment where some of them are working remotely and some employees are working from the office, and they just need more flexibility. So this is where AppStream 2.0 comes into picture. So AppStream 2.0, like I was mentioning, it is a fully managed application streaming service. So even though I say application streaming service, it has features where end users will be able to see full desktops while also streaming their applications. And the good thing with AppStream 2.0 or with even Workspaces, which is our second end user computing service, is that administrators are able to fully customize and optimize the end user experience. So what I mean by that is, before an end user even connects to their device or their virtual desktop, administrators are able to fully test out their performance, how the application is performing, how the desktop is going to look like when an end user logs in. So that's what we mean by admin curated, and it integrates really well with your existing Active Directory infrastructure or other authentication options, which we're going to discuss in a few minutes. So I used the word fully managed a couple of times already. So what I mean by fully managed is, let's start about what managing a VDI really means. So this is kind of an extreme spectrum. So on the left side of the screen, we see on-premise VDI, or to your right actually, on-premises VDI where everything has to be managed by the IT staff, or somebody in the organization has to take ownership of the rack and stack, the administration overhead, as well as the image management. Whereas with other cloud providers, there's some flexibility when we talk about other cloud VDI, where half of the responsibilities are taken by cloud providers and the other half kind of falls into the customer's lap, where they have to maintain the image. They also have to maintain some of the streaming servers. But the good thing with AppStream is everything from rack and stack all the way up to VDI control plane is managed by AWS. So what I mean by that is, when an administrator or when an organization is thinking about using AppStream 2.0, all the administrator has to do to onboard employees or end users, they only have to create a golden image. So install the applications and deploy that to end users, and they can start streaming instantly. So I've kind of separated the use cases in three different sections. We have also found other use cases industry-wide, but the three most common ones that we found were with enterprise customers. So with enterprise customers, they were more so, or they have been more so using it for an on-premises VDI migration where they have or they were managing their own on-premises VDI and they migrated to AppStream 2.0 just to reduce that administrative management overhead. On the other side of things, we have educational customers. So educational customers have been using AppStream for delivering courses, labs to students because from their perspective, their students really don't need fully persistent desktops that they need to save their data on or do any kind of a persistent work in. So that's why it's really handy for educational customers to use AppStream for delivering those courses and labs. And then for ISVs or independent software vendors, AppStream comes in handy because it's really easy for ISV customers to deliver just a little glimpse of their product using AppStream, because a really good example is SolidWorks. And we're going to talk about SolidWorks here just in a little bit. So SolidWorks is using AppStream for demoing their product to their customers or prospects. So if you go to SolidWorks website and if you try on the SolidWorks product, it's actually being hosted on AppStream 2.0. It is being delivered through a browser, but on the back end, it's AppStream. So we talked about SolidWorks. There are a variety of other customers, General Electric, Samsung, and there are some other customers as well that are using AppStream 2.0. I've curated a list of use cases and how customers are using it, more so success stories, and we're going to talk about that more towards the end of the session. So let's take a look at the overview and benefits for AppStream. Before we talk about the benefits, let's take a look at the challenges that IT or organizations in general are facing when it comes to on-premises VDI or VDI with other cloud providers. So when we talk to customers before onboarding them, they usually tell us that the IT staff has to buy hardware, at the beginning of the year or at the beginning of the quarter. So they always have to predict usage for the number of end users or employees that are going to be onboarded. And they never really know what that number is. So either that results in buying a lot of hardware, or sometimes it results in not buying enough. So what happens is they end up predicting usage, and at the end of the quarter or during the year, they're not able to fully meet the demands of the employees that do end up getting hired. So it's slightly inconvenient for them. And there are some other challenges that organizations are also running into, and one of them is bring your own device or BYOD. So customers and users in general want the flexibility to be able to use their own devices to connect to a virtual desktop. So with on-premise VDI or with other cloud providers in general, there are some restrictions with the type of devices that you can use to access a virtual desktop, which is not the case with AppStream 2.0. And then security is the number one concern, especially in the last 5 years with all the threats that we have been seeing in the security side. So we're going to discuss security, but I just wanted to also take a minute to talk about the scaling aspect. So because every organization or almost every organization is virtual these days, customers really want to be able to provide virtual desktops across the country or even across the world. So it becomes really hard for customers to deliver those desktops virtually or ship expensive hardware that may cost $2,000 to $4,000 for contractors or for users. So This is also where AppStream comes in really handy, where you're able to scale out to up to 1,000 instances within a matter of few minutes. So when we talk about AppStream 2.0 as an overview, when we discuss the security aspect especially, apps and data are co-located in AWS, and only encrypted pixels are streamed across the wire. So end users, when they're streaming their virtual desktop or their applications, they are only streaming the pixels. They're not downloading any data to their own machine. And the benefit with AppStream also is that administrators have full control over what end users can do, as far as being able to copy and paste, as far as being able to upload and download. And there are some other functionalities that administrators can control. So when we talk about the benefits, security is definitely number one, where because no data is ever downloaded onto an end user's own machine, they are able to, or when I say they, the security teams or the IT teams have the ease of mind of being able to deliver the apps or desktops that they want to deliver without having to worry about exposing sensitive data or private data to an end user's personal device. So we talked about the fully managed aspect. So now let's also talk about pricing. So usually with on-premises VDI or with other cloud providers, there's an upfront commitment or there are some long-term commitments in some cases where whether it's buying hardware or signing licensing deals that span over 1 to 3 to 5 years, there's a lot of investment that goes into it. When I say it, I mean virtual desktops before actually being able to use them. But with AppStream, one of the biggest benefits also is pay-as-you-go pricing. So whether you want to use AppStream for a proof of concept or whether you want to use it in production, you don't have to make any investments or any long-term commitments from a pricing standpoint to be able to use AppStream. And then the other benefit that I would like to kind of focus on before diving deep into each one of them is high reliability. So AppStream is a highly available service in a sense that when you're deploying AppStream instances in an AWS region, the fleet instances are actually split across 2 availability zones, and you can define more availability zones that you want your fleet instances to be deployed in. So for example, if you are deploying in US East 1, you can choose US East 1A, US East 1B, and 1C for your fleet instances to be deployed. So what this really does is it really helps with the fault tolerance aspect, where if for some reason an availability zone goes down, there's flexibility or there's ease of mind as far as the instances being deployed in a different availability zone, which is still functioning, so that end users never have to see any downtime. So we talked about the fully managed aspect, and just to quickly recap also, when we say fully managed, the underlying resources that are required to stream and host applications for end users are all managed by AWS. So at any given time, the administrators or organizations do not have to worry about the hardware, infrastructure, whether resources will be available when the users are trying to use or access their desktops, virtual desktops. That is not the case. It is all managed by AWS, and at any given time, customers will only have to take care of or manage the images themselves. Security. So we talked about how the data is never actually downloaded on an end user's device, but I also want to talk about a few other security features that have to do a lot with authentication. So recently, a lot of organizations have onboarded SAML or single sign-on, where they're using an identity provider, and that identity provider handles the authentication needs for an organization across the board. So it's not just virtual desktops anymore, it's other applications that their end users are using. With AppStream 2.0, administrators can integrate most SAML providers or single sign-on providers within AWS so that users and even administrators do not have to manage different set of credentials to access their virtual desktop. So it not only does it add ease of mind when it comes to authentication security, it also reduces the management and rotation of passwords and usernames when it comes to logging into their virtual desktops. Scales on demand. So the biggest benefit, or one of the biggest benefits with AppStream also is scaling. So with AppStream, there are two types of scaling policies that administrators can configure. One of them is schedule based. So let's say if you predict usage from 8 a.m. to 5 p.m. So AppStream can be configured in a way that at 8 a.m. in the morning, 100 instances are spun up if you're trying to serve 100 end users. And then at 5 p.m., all of those scale back down and you only have maybe 10 or 5 remaining. This would really depend on the type of configuration you want at the end of the day or the beginning of the day. And then the other is utilization based. So we talked about schedule based. With utilization based scaling, and administrators can define policies where if there is certain demand, doesn't have to be at a certain time of day. It can be throughout the day, anytime. If 10 users are trying to connect at once, they can define policies where 10 fleet instances can be made available almost instantly to those end users. So we talked about pay-as-you-go pricing a little bit. This applies with AppStream as well as Workspaces, which is our second end user computing service. There are no upfront costs or long-term commitments, but with AppStream, we have two billing models. Both of them are hourly. So the two billing models are always on and on demand. The difference between the two is really the connection time that the user will see at the beginning of their session. But we're going to dive deep into both of them not at the end, but just in a little bit at the end. I have a demo which shows the difference between on demand versus always on. AppStream integrates with your existing system seamlessly, and this doesn't just apply to authentication options with SAML providers, it also applies to Active Directory. So if customers are using Active Directory on premises or with other cloud providers, then they can continue using the same Active Directory domain for authenticating into the AppStream instances as well. So that handles the authentication portion, but it also further extends into being able to manage the computer objects as well as the user objects that are created within Active Directory. So if customers have group policy objects or SCCM policies that handle the patching and application management, then all of those existing policies can directly be applied to the computer objects that will be spun up when users try to connect to their fleet instances. AppStream 2.0, being an application streaming service, comes in really handy also that in a way that administrators do not have to worry about installing an upgraded version of the application on each user's device. They can update their golden image with the most up-to-date version of the application, and they can apply that golden image across the board to all the fleet instances that are spun up so that the next time a user logs into their instance, they're seeing the most up-to-date version of their application. So it reduces management overhead, not just from an operating system and patching standpoint, but also from an application versioning standpoint. And it integrates seamlessly with Windows as well as Linux operating systems. So Linux was support for Linux instances was recently introduced, but at the moment, Windows and Linux can be spun up on AppStream. So we talked about how AppStream can be deployed in multiple availability zones, and You can do this using the AWS console, and we also have API calls that you can use to specify the availability zones that you want your AppStream fleet instances to be deployed in. The service has a 99.9% SLA, so to translate that into months and hours, we're looking at about less than an hour's worth of downtime in any given month. The good thing with AppStream is that it uses a protocol called nice DCV. So nice DCV protocol operates over HTTPS port 443, and it is designed in a way that it adapts the network according to the network conditions of the end user. So if they're seeing fluctuations in their bandwidth or if they're having network issues, they won't be instantly disconnected and they won't instantly start seeing poor performance. It is optimized to provide best responsiveness for streaming instances. We talked about how AppStream is scalable and can be deployed in multiple availability zones within a single region, but AppStream is currently available in the regions that you're now seeing. So this is in different continents and different countries. You can define scaling policies with AppStream where your golden images can be copied over to different countries or different continents. So if, let's say, if your primary region is Oregon, US West, and if you want to fail over to Mumbai or Tokyo, you can copy the golden images beforehand and have policies defined in advance that in case of a disaster recovery event or in an unexpected or unfortunate event, all of your end users can instantly fail over to a different region as well. And when we talk about security and when we talk about the data never leaving the VPC or the virtual network within AWS, it's also important to discuss the compliance mandates. So AppStream is currently compliant SOC, PCI, FedRAMP, and the other compliance mandates that you're seeing on the screen. All of these reports are available within AWS Artifact to download, so you can provide that to your auditors or organizations that that basically state that your organization is compliant with these mandates. So let's discuss pricing. So I talked about two billing models with the two different feed instance types, always on and on demand. But I also wanted to talk about the two different types of fees. So with AppStream, there are two types of fees. One is the streaming cost itself. So this would be the number of hours that your fleet instances are running. And the other is user fees. So this is applicable for Windows AppStream Windows instances where if a user connects to their AppStream instance even once during a given month, they would be charged with a $4.19 for RDS SAL fees. Now, some flexibility here is if you already have your own RDS SAL licenses, we do allow customers to bring your own licenses. So you can rule out those fees for RDS SALs. And the benefit with educational customers is that there's a discounted pricing for RDS SALs. So it's about 44 cents per month. Now, when we talk about streaming costs, there are some variables here as far as the type of fleet that you have running. So with always on, it would be running 24 hours of the day. With on demand, it's slightly different where your fleet instances would be running depending on the scaling policies you define for a fixed number of hours. So let's say that's 8 hours or 10 hours, depending on your use case. So you would be charged only for those number of hours in a given day or a given month. And the pricing would also vary depending on the type of instance you choose. So if you choose an instance with graphics or GPUs, the pricing would be different compared to a standard instance. Now let's talk about always on versus on demand and elastic fleets, which is one of the newer features that was introduced at reInvent last year. So with always on fleets, because the instances are running at all times, your end users would be able to instantly connect to their fleet instance, so there's absolutely no wait time. Whereas with on-demand fleets, there is a less than 2-minute wait time. So when the users connect to their instance, they will see a timer counting down from 2 minutes to 0 seconds, and that's the amount of time that they'll have to wait. In the back end, AppStream is starting out the fleets and making sure that users are able to see their desktop sessions. Whereas with Always On, because they're already running, users are directly able to connect to their instances. Now let's talk about elastic fleets. So this is a newer feature that was recently introduced. The good thing with elastic fleets is that customers do not have to worry about auto scaling policies in elastic fleets, because AWS takes care of auto scaling policies and it manages them. So there's no need to predict usage and configure schedule based or capacity based utilization. All of that is managed by AWS, and you're paying by the second or paying per second instead of paying by the hour. One thing also with Linux instances, there is no RDS sal fee because you're connecting to Linux and not a Microsoft Windows system. So I just thought it would be worth pointing out. And with on-demand fleets also, because your instances are only running, let's say, 8 hours a day or 10 hours a day, there is a very small hourly fee for the number of hours that your instance is not in the running state. So that's important to note, and that doesn't apply to Always On and doesn't apply to elastic fleets as well. So I think it's a good time to discuss the architecture. We talked about the scaling aspects, we talked about security. Now let's take a look at what really happens when an end user is trying to connect to their AppStream fleet instance. So when we talk about end users, even though in the diagram it represents on-premises, they could be located anywhere, across the globe or across the country. And usually they are trying to connect from the internet. So when they try to connect through the internet, the first thing is authentication. So the authentication would go through, as you're seeing, through a SAML provider. Usually there are other options to configure authentication using a local AWS user pool, which is an AWS native feature. But whether it's user pools or SAML, the first step would be to make sure that credentials are valid and there's an authentication issued by the SAML provider. Once they have that token, they are connected to a streaming gateway. Now, streaming gateways have basically, there's two aspects to streaming gateways. One is it lives within an AWS VPC, AWS managed VPC, and it has two different endpoints. So there's a public endpoint for streaming gateways, which is what the end user will be connecting to, and then there's a private endpoint. So with the public endpoint, when the end user is authenticated and they have a valid authentication token, they are connected to a streaming gateway. The streaming gateway then privately connects to the AppStream instance on the backend. So that's where you're seeing the fleet in the AWS VPC, AWS managed VPC. So at any time, the AppStream fleet instance that a user is connected to is never exposed to the internet. The streaming gateway acts as a proxy between the end user and the AppStream instance. Now, there are other ways to connect as well. We have a feature using VPC endpoints where the streaming gateways can have only private endpoints, where the streaming also happens through either a direct connect or an AWS site-to-site VPN. So only the authentication piece would have to touch the internet, and that's only because most SAML providers require connecting to a public authentication endpoint. Now, whether it's using a VPC endpoint or whether it's using the public streaming endpoints, The streaming gateway basically initiates and maintains the connection between an end user and an AppStream fleet instance. So the streaming gateway, in a way, is acting as a middleman or a proxy between the end user and the AppStream instance. Now, there are other things displayed here as well that talk about AWS services or resources. This really depends on the use case. Now, we have a lot of customers that have file servers or licensing servers within AWS VPCs. It becomes really secure and convenient for customers to be able to configure their VPCs in a manner that those AppStream fleet instances are able to privately connect to the licensing servers or file shares, depending on the type of resource it is. And then, of course, Microsoft Active Directory is listed there. Active Directory can either be within AWS or on premises, but this just represents that AppStream fleet instances are privately joined to the domain, regardless of where the domain is located. I also wanted to talk about persistent user storage and home folders, which is listed here, but I have a slide for that. So we'll talk about that as well. So we discussed support for Linux. Now with Linux, so AppStream uses Amazon Linux too, and there are two views or two types of fleet instances that a user can connect to. So one is the desktop view, where a user would be presented with a full desktop. This has the graphical user interface, whether it's a Windows or Linux instance. They will be able to see a graphical user interface and navigate between the applications or the different home folder options using the graphical user interface. And then there is the app view, which only displays the applications. It is still hosted on the same OS, so depending on whether it's Windows or Linux, it would still be hosted on that operating system, but the users won't be seeing a graphical user interface as far as the start menu or the desktop. And then even in the case of Linux, they won't be seeing the Fedora-based graphical user interface. So the good thing with Linux, like I was mentioning before, no RDS SAL fees. Users can directly connect to their Linux fleets without having to worry about that. And as far as open source compatibility, there are certain applications that only work with Linux, and there are others that only work with Windows. So this just provides that flexibility between choosing the right operating system. And one last thing before I move on to the next slide as well is that with support, when it says support for Linux, this is the Linux operating system within AppStream that the end user is streaming. The end user themselves can use a Windows machine or a Mac or a different type of machine to connect. There are no restrictions on the base machine. As long as they're using an HTML5 compatible browser, they can connect to their Linux fleet instance from any device. Elastic fleets. So elastic fleets are a serverless fleet type that are managed by AWS. When I say managed by AWS, it means the auto-scaling policies are managed by AWS as well as the underlying resources that host applications. So the advantage with elastic fleets is that the administrators do not even have to create golden images within the AppStream console. So the way that elastic fleets work are they rely on virtual hard disks. So administrators would install and configure their applications within a virtual hard disk. And this virtual hard disk would be in an S3 bucket. And that elastic fleet session will be based off of the S3 bucket that has the application. So this is usually more suited towards use cases that don't require, or applications that don't require a lot of configuration. You just put them in a VHD or virtual hard disk, export it to S3, and then AppStream will base off the streaming instances using the elastic fleets. And then, like I was mentioning, there's no need to predict usage or configure scaling policies or even manage golden images. Let's talk about how end users access their AppStream 2.0 streaming instances. So I use the word HTML5 compatible browser, which is correct. So regardless of the type of operating system an end user has, whether it's Windows, Mac, or Linux, as long as they're using an HTML5 compatible browser, they will be able to connect to their AppStream Fleet instances. Now, there's also a client for AppStream, which is only supported on a Windows operating system. So what I mean by that is if an end user is using Windows OS as their base machine, they would be able to download a Windows client for AppStream 2.0 and be able to connect. Now, the common theme with both is USB redirection. So when I say USB redirection, I mean webcams, microphones, smart cards, printers. The AppStream 2.0 client has slightly more flexibility as far as what you're able to redirect. So it supports smart cards, whereas with the browsers, you are able to redirect microphones and webcams. With the client, you're able to redirect smart cards, 3D mice, and some of the other advanced peripherals. I mentioned application view and desktop view. Just to put things in perspective, I do have a demo, which I'll be showing shortly, that shows the comparison between those two views. So desktop view, again, it's more suited for end users that want a graphical user interface to stream their applications, and we'll be taking a look at that here in just a few minutes. And then AppStream 2.0 client, like I was mentioning, more support for peripheral devices, so smart card, 3D mice, or 3D mouse, and a local file and printer redirection as well. Native application mode is a unique feature with AppStream 2.0 client for Windows, where the way it works is, if let's say if a user is using 4 applications within their AppStream Fleet instance, if they enable native application mode, it would appear to the user as if those applications are launched on their base machine or on their local machine. So it would show those 4 windows in the taskbar and make it appear to the user as if they're actually running on the user's local machine, but they're actually streaming it via AppStream. Tablet support, so this applies for Safari, Google Chrome, again, HTML5 compatible browsers on tablets. Persistent user application settings. This is a feature that provides a persistent experience when it comes to AppStream. So it adds a slight level of persistence where if users customize their browsers, or if they save favorites or do some kind of a customization, at the application level, those customizations will persist regardless of how many times they log in and log out of the session. Administrators are able to control if a user can copy and paste data, if they can upload and download data from the instance to the local machine. So there's a lot of flexibility for administrators to actually control the end user session. AppStream allows administrators to configure their fleet instances and even maintain them using API calls. So AWS CLI tools, AWS SDKs that administrators use on their own local machines, they can manage AppStream resources using APIs. Use cases. So a lot of our customers are using AppStream for a variety of different use cases. So General Electric here, they were doing more of a traditional on-premises VDI migration. So they migrated their on-premises VDI and they were able to scale on demand for their end users. And they saw a lot of success with that. And when we talk about graphics applications, usually customers have to buy expensive hardware, which costs about $5,000. Customers really wanted a way to be able to provide that graphics heavy or GPU experience to end users without having to pay for hardware. So with our GPU enabled instances, Samsung was able to use graphics instances on AppStream and was able to deliver to their end users and customers. So with Tidewater, their use case was more so integrating Windows applications, and because AppStream has supports Windows OS for virtual desktops, they were able to use Windows applications within their AppStream instance, and their end users were able to stream them virtually. ISV. So I talked about SolidWorks at the beginning. So with SolidWorks, they were able to integrate their online trials and their software demos within AppStream. So through the browser, they were able to deliver that to their prospects. And then education customers. So Macquarie University was able to provide access to applications or coursework to their students, and students had a lot more flexibility as far as bringing their own device and still being able to stream the courses virtually. Now let's take a look at a demonstration. So we'll get right into it because the Linux support is a newer feature. I started with that demo first. So an end user can connect to AppStream using SAML, user pools, and then there's a programmatic way called streaming URLs, which is what I used here in my demo. So as you see that desktop icon over there, so this is the desktop view where the end user can select desktop and they'll be presented with a full desktop. Here I was only using Chromium as my sample application. Of course, administrators can configure their golden images to have more applications. So this one has a graphical user interface and I have Chromium installed. Some of the other sample applications are also here, so like terminal and file and system settings as well. But those are all locked down and can be controlled by administrators. So there at the top left there's an application catalog and a switch windows button. Those are more so applicable for the app view. And then there's the button for accessing home folders. So home folders is a persistent storage within AppStream where if a user saves anything in home folders, it will persist regardless of the number of times they log out and log in. There are other features for copying to the local device and pasting to remote session. This is more so for clipboard redirection. So if there are certain text that a user wants to copy from their device to the machine or vice versa, they can do it. And there are options to change screen resolution. So this is more so suited towards applications where if a certain application operates at a very specific screen resolution, then the end users can choose that. And users can also choose to go into full screen mode or have multiple monitors as well. I'm now going to switch over to a Windows virtual desktop or Windows instance within AppStream. So as you can see at the top pane, all of the options are the exact same, except for the operating system itself, which is based on Windows. I have AutoCAD and Photoshop installed on this one. So this is more so graphics heavy. And then, of course, some of the sample applications are automatically included, like Firefox, File Explorer. It has more flexibility. If I want to switch from one app to the other, I can do it using the Windows graphical user interface. So now I'll be connecting to the application view, which is different than the desktop view that we saw for Linux and Windows. So when we get connected now, we don't see that desktop icon that we were seeing previously. It just shows a bunch of applications. Now, regardless of the app I choose to connect to now, I will have the option to connect to other applications afterwards using the switch windows button that I was showing earlier. So that's more suitable for application view. So with application view, because I chose Firefox kind of opened up first. Now, if I want to use different applications and I have some sample applications installed in this demo, I can choose to launch them at any given time. And Firefox will still be running in the background. So again, this is not any different from the desktop view. It has the same functionality. It just doesn't have, as you can see, it doesn't have the start menu. It doesn't have the background. Now, when I minimize everything here, it's just going to show like a black screen. And the way that I was just clicking on the switch windows button, which shows the 3 windows that I have open. And that's how you would typically go into one window or another. So this is the black screen that I was talking about. But again, if I click on that switch windows button, it shows me other applications, and I can choose to maximize one and minimize the others. All of the functionality at the top is the same, so enabling microphone, webcams, full screen, all of the features are consistent. Desktop view and application view just have different views, and these are more catered for end users who are either used to using a graphical user interface, or if they don't want a graphical user interface, they would use this, the app view. For next steps, of course, you can go onto the AppStream 2.0 public website, and you can try sample applications using the AWS console. Alternatively, you can also schedule a deep dive with us for a specific use case, and we can help you kick off a proof of concept. There's additional training resources available online. So if you want to scan those QR codes to access the variety of different free courses that we have available and certifications as well, you can choose to do so. And that's it for today. Thank you very much for joining the session. It was really good to have you. Hopefully, you're more informed about end user computing on AWS now than ever before. But we appreciate your time. I'll be at the back of the hall for additional questions if you want to have that a little discussion with me. But thank you for joining me for this session.